Hello there students, good afternoon and welcome to the new episode which is directed to the IGCSE level. In this past paper I'm going to solve the questions which are related to the alternative to practical, that means practical theory. This series actually it says February-March 2016. I'm going to start with the question number 1. Here we have the question number 1. The diagrams shows the apparatus used to obtain crystals of calcium chloride. So you need to form calcium chloride from a mixture of solid calcium chloride and solid calcium carbonate. So used to obtain crystals of calcium chloride from a mixture of solid calcium chloride and calcium carbonate. That means both of these solid compounds, they are in a mixture, and what we want only calcium chloride. You have in the question number 1, complete the boxes to name the apparatus. Here was the name, the apparatus in the diagram A. It's very clear, it's tripod, which is a stand. In the second box in the diagram B, you have this stirrer, stirrer rod, stirrer, or you can say a glass rod or stirring rod, glass rod. Okay. Here you have Bunsen burner. You have here glass watch. These are extra glass watch. Here you have beaker. Here you have funnel. You have here still glass watch, and here you have this one. It's filter paper. Sorry, filter paper. So in the question A, only you need to fill these two boxes, tripod and a stirrer or glass rod. In the question B, write down the order in which the apparatus should be used in this experiment. So here to obtain the crystal of calcium chloride, first of all you need to mix both of the solids. So the mixture here in the B, that means first of all you need to say B. Then after that the calcium chloride, it will be soluble, and the calcium carbonate, it will be insoluble. So here in the filter paper it's calcium carbonate, and here, which it comes from the filter paper, it's calcium chloride, but it's soluble in water. So then C, after that you are going to evaporate the water to have the crystals. So then A. So the order B, C, A. Name the separation process in C. What's the name of the separation? It's filtration. Filtration by using phenol, and in the phenol there is a filter paper which is trap the insoluble things, which are calcium carbonate, and the solution, or the solution which pass through the filter paper, it's the solution of calcium chloride. what has been added to the mixture in B? In the mixture B, you have mixed calcium chloride and calcium chloride, both of them. And here what do we have in the beaker, which is filled to this level? Clear, yes, it's water. Water. Because you started with both of them are solids. You have dissolved them, then the calcium carbonate insoluble, calcium chloride is soluble, you have obtained it. What's the general name given to the liquid in the dish? In C. Here, this one. What's the name of this liquid which it comes from filter paper? It's called filtrate. The filtrate, the solution which passed through the filter paper, which is filtrate. A question D, how would you know when to stop heating in the dish, heating the dish in A? Here, after that, you transfer this part from the diagram C, you put it under heating here by using Bunsen burner to evaporate the water to obtain the calcium chloride. So you are going to heat, but when you are going to stop, till you will obtain a solid. That means solid appear on the edge of the glass watch, or also we can say by using a glass root test. When you are going to scratch the solid with this glass rod, if there is something stick on the glass rod, that means it's still hydrated. You need to continue to heat this calcium chloride. So if there is nothing is stick on the glass rod, that means it's totally dried. So you can say solid appear on edge of the glass watch, or you can say just glass rod test. This is question 1, and question number 2. Here you have a teacher investigated the rate of reaction between two solutions, J and K, with sulfuric acid. That means you have two solutions and each one is reacted with sulfuric acid at different temperature. That means here rate, okay, temperature, and also different solutions. So that means if it's different solutions, that means maybe they have different concentration. Maybe this one, I'm not sure. Different concentration. In the experiment 1, a large measuring cylinder, you have used measuring cylinder, which is this one. Sorry. Measuring cylinder, this one, was used to pour 50 cubic centimeter of distilled water and 40 cubic centimeter of sulfuric acid to conical flask. Conical flask, this one. This one, conical flask. From its shape, it's conical. A small measuring cylinder was used to add 2 cubic centimeter of methyl orange, its indicator, and 5 cubic centimeter of solution J. So here you have started with J to the mixture in the conical flask. Then the temperature of the mixture was measured by what? By thermometer. The reaction was started by adding 5 cubic centimeter of K. That means here the question here, you transferred to the conical flask water, then 40 cubic centimeter of sulfuric acid, and then you add 2 cubic centimeter of methyl orange, and then 5 cubic centimeter of J. At the end you have added K. All of them where they are added in the conical flask. So when you will add the K solution to the conical flask, immediately you are going to start timer. And swirling them mixture, that means you have to stir it, you have to shake it. The time taken for the mixture to turn pale yellow, that means the color, it will be converted from methyl or from the orange to yellow. The final temperature of the mixture was measured. Here you have measured the initial temperature and final temperature. Experiment 2 is repeated, but here in the everything is repeated totally same, but here the temperature is set to at 30 Celsius before adding these solutions. So that means the initial temperature for the experiment 2, it's 30. And the experiment 3 is repeated again. Here you have increased the temperature. The initial temperature for experiment 3, it's 40. And for the last experiment, which is experiment number 4, it's 50. Okay? And in each experiment, you have recorded the time, everything, and the teacher got this table. So this table here, just let's okay, nice. So in this table you have number of experiments 1 2 3 4 and stop clock diagram, time taken for mixture to turn pale yellow in a second. You have to calculate it from this stop clock diagram. Initial and final temperature are given also in the table, just you need to calculate their average. So here we need to calculate the time. It's in a second. Here the time in a second. You have in the stop clock 2 circles. The outer one, it's representing the second, and the inner one, it's representing the minutes. You have clearly 2 minutes and 8 seconds. 2 minutes, that means 60 plus 60, 120 plus 8. So the time which is taken for mixture to turn pale yellow for the first experiment, it's 128. The average of temperature, just you need to add them together over 2, so you will get 16. For this experiment number 2, you have 0 minute with 58 seconds, and the temperature plus over 2, which is 27. This third experiment, it's 0 minutes actually, and 27 seconds with average over 241. The last experiment, it's 16, 17, 18 seconds with 50. Okay. Then you are going to draw these 2 columns. Time taken for mixture to turn yellow versus average temperature. Already I have plotted these results on the grid. Just we need to draw a smooth line to connect these points. So you will start from this one. Maybe you will do it better than me. Like this one. Actually, I need to repeat it. This one. I think it's better. Okay. Okay, then question C from your graph, deduce the time. That means deduce, you need to take it from your graph. For the mixture to turn pale yellow, if experiment 1 was repeated and the average temperature is 60, that means temperature here is 60. In your opinion, what's the time it's taken to turn the yellow of the mixture to the pale yellow? You will continue with this line till the 60. So till the 60 you got, what's the time of this one here? It's a 12 second. How did you get this 12 second? By extrapolating. Extrapolating, or extra drawing, you can say. Okay, so in the next question, in which experiment was the rate of reaction greatest? It's very clear in the experiment number 4, only the time which is taken to turn the color of the mixture to pale yellow, it's 18 seconds. That means this is the rate of reaction greatest, which is experiment 4. Why? Because more energy, high temperature, it was 50. These are enough. You may say the chance of collision between the particle, it was more, so the rate of reaction, we have this. But according to the question, 2 marks, that means you need to explain 2 reasons. Suggest and explain the effect on the result if you have used burette instead of the measuring cylinder. Look at here, please. And this question, always this question is frequently repeated. So measuring cylinder, this one, is used to transfer the liquids. Burette with a tap here, and also it's graduated. Also it's used to transfer a liquid. In your opinion, which one is more accurate? Which one it will give us accurate results? The one, any apparatus with a very small diameter, the diameter here smaller than this, so this one it's more accurate. So burette and this one measuring cylinder. So this one more accurate, so the result it will be more accurate. Suggest and next question, suggest and explain one other improvement. How you are going to improve this experiment, adding to the using of burette instead of cylinder. You can use a digit stopwatch. Or stop clock. Stopwatch, it's more accurate than normal one which is drawn in the diagram. You can say using digit thermometer instead of the normal thermometer. You can say do we have another you can repeat the experiment at least for 3 times, then you will take average. Okay, so all of these options will give us more accurate results, or these are options to improve these experiments. So by the end of this question, we have arrived to the end of this episode. So see you in the next episode to solve question 3 and 4. See you.